360 because
So
I
what?
thought I thought the angles on a straight line adds up to 180. So
Yes. So don't worry, I'll explain it. Now that's why I said the sum of exterior angles of any shape is 360. That means that don't worry. Well, let me produce all the exterior angles in this shape. Then I'll show you what I explain better what I mean. So
mhm.
yes, look at this other angle here. So I want to create another exterior angle here. I want to create exterior angle here. Okay. So look at this. Um, can you see that angle I just drew now?
Yeah.
Uh-huh. That's another exterior angle. So let's pretend that this angle is angle A and this other one is angle B. And then I now have a third angle. Let me produce a third angle. Okay? And I do this. And again, remember, exterior angles are gotten by extending one of the sides of the shape. Just draw it, keep drawing it like a straight line. Take note, it has to be a straight line. So that's way
Oh,
and be sure that it's an exterior angle. So now let's pretend that this is angle C. Okay. Now angle A, based on what I just said now, angle A plus B plus C will be equal to what?
360.
360. Now, I know what you mentioned something about angles on a straight line. I'll come to that. So let's now talk about angles on a straight line. You remember when I was telling you that there's a relationship between the interior angle of a shape and the exterior, the corresponding or the adjacent exterior angle to that shape. This is what I meant. So can you look at this angle here? This angle here is what? 180 minus A, isn't it?
Mhm.
Uh-huh. So what does that tell me? It means that every every exterior angle plus the adjacent exterior angle would always add up to give me what? 180. You get that?
Yeah.
So does it not make things, kind of add up? So now that means that if I know the interior adjacent exterior angle would do what? Be equal to 180 minus that interior angle. Did you get that?
Yeah.
Okay. So now let's go back to that first one that we just, looked at. This, can you see the exterior angle of this triangle here? Look at this. Can you see what I'm drawing?
Hmm.
Uh-huh. And I'm now extending it, though I'm not using a straight line, but let's just pretend that it's a straight line that I'm using to extend it. So now, this exterior angle, what would it be if I were to calculate it based on what you just discovered? Would it be
So would it be uh, uh 180 minus 43? 3,
180 minus 43, isn't it?
yeah, 137.
100 and what?
37 degrees.
Yes, 137 degrees, correct. Okay, so that's good. Um, yes, so that's 137 degrees. Okay, so I'm not sure I've taken note of that fact that I just mentioned now. But then let's just say we have these three facts now. At least this will solidify your understanding of the of interior angles and exterior angles. So I'm going to um put down that next fact that we said that. um, um, each the sum the sum of each in- interior angle, okay, and its sorry, I think it's just its without apostrophe, and its adjacent, okay, adjacent, okay, um, exterior angle 180, sorry, 180 degrees. Okay, so I'm going to sketch that out and something like this. Okay, so do you understand it so far? You understand it so far?
Yeah.
Okay, good. Any questions so far? Any questions? Yeah. Hello.
Hello?
Yes, I said, do you have any questions?
No, no, no.
Okay, so we want to quickly recap what we talked about, right? Went to, then we now went on to about the of any shape of 260 and went on to uh, where we saw the relationship between what the interior angle. Okay, so what other concept different from did you guys cover? Was there anyone that looked like this but to what I've said so far?
Pardon?
Can you hear me?
Yeah.
Okay, so I said, are there any ones that look different from the ones what I've just communicated?
Wait, how would
Okay,
you see in this third one, how would you find out what A, B, and C are?
okay, in that case, it depends. I just use A, B, and C to be able to
Oh,
explain. Yes, it's not like an actual question. You get
yeah, I don't have
okay,
any.
okay, all right. So let's look at um right angle triangle. Now you see, this concept I've showed you, right, apply to all the triangles that which we can think about. You can think about isosceles triangles. You know what an isosceles triangle is? Hmm.
Pardon?
You know what an isosceles triangle is, right?
Yeah.
Okay. So I said this concept will apply to isosceles, saline, and equilateral triangles. Now, right angle triangles open up a whole new world. Mason, can you hear me?
Yeah.
Let's look at right angle triangles. So, what makes a right angle triangle a right angle triangle?
Pardon?
What is unique about a right angle triangle?
What's it? I don't know how to explain it.
There
Um,
should be property that you can say stands out. What's that?
I don't know how to explain it. Like,
So how would you identify a right angle triangle? How would
like
you know? Yes, by
if
just seeing, yes,
like if I don't know, I don't say no. I don't know how to explain it. All I know is that like the lines are straight on the bottom and the line on the left or right, if depending on which way it's facing.
lines. Okay. So basically a right angle triangle is a triangle that has one right angle, and that right angle is 90 degrees.
Mm.
Okay. So you can you see the shape I just drew now.
Yeah.
So that's one there. That let me use an arrow to point to this angle that is here. Can you see that arrow pointing to the angle there?
Pardon?
Can you see the arrow I just drew pointing to that
Yeah.
angle? Okay. So that angle is called a right angle. Okay. That is what makes this triangle unique. Okay. That's why it is called a right angle triangle. So a right angle triangle is simply what? A triangle that has a right angle in it. And a right angle is what? 90 degrees. Did you get that?
Mm.
Okay. So now I'm not going to, I'm sure we will not be able to cover everything about it tonight, but at least let me just see if I can do a bit of an introduction, right? So now, if you are sure that this angle is 90 degrees, what does that tell us about the remaining two angles here and here? What does that tell us? What do you think that tells us? Remember, the sum of angles in a triangle is 180, and
Yeah.
one already, we are
So
sure
because
90,
it's
yes.
180, that means that the other two together should equal up
Yes.
to 90 as well.
Thank you very much. Yes. The other two, adding them together should be equal to 90. So that will now make the total to be what? 180. And that is what you just said now is very true. Now, another concept, right, that I want you to see is the fact that these other two angles are called complementary angles. When two angles, you add them up and they give you 90 degrees. They are known as what? Complementary angles. So don't forget that fact. Okay. When you add two angles together to give you 90 degrees, they are complementary angles. For instance, if I know that this angle is 60 degrees, for instance, automatically this second one would be how many degrees? This second
So
one would be how
if that one is 66, the second
no,
one,
it's 60.
wait, oh,
It's 60.
60, sorry. I thought I was
Yeah.
66.
Okay, no. I said 60. So if this first one is 60, this second one would be what?
The second one would be, Chai. Second one would be 30.
30, correct. So that's it. It's very easy. Can you see that? So
Yeah.
that's the thing about right angle triangles. You already know one of the angles is 90 degrees. It's an established fact. That's why it's a right angle triangle. Now, one other thing that you need to understand is this. Don't ever assume an angle is 90 degrees just because it looks like one line that is vertical met with one line that is horizontal, except there's an established fact. somewhere in the question that tells you two lines are perpendicular to each other, they met, and then even if they didn't tell you that the angle between them is 90, guess what? The angle between a vertical line, a perfectly vertical line, and a perfectly horizontal line would be what? What angle would be between them?
Um,
Perfectly vertical, perfectly horizontal. What angle will be between them?
Wait, can you repeat the question, please?
Angle would be between two lines, one perfectly vertical and the other perfectly horizontal.
Between two what?
Two lines, two lines.
Two lines. Yeah.
One is perfectly vertical and the other perfectly horizontal.
I'm not sure.
It's 90 degrees.
90. Yeah. Oh.
Yes, it's 90 degrees. A vertical line is this line that you're looking at, this one that I'm pointing this arrow at now is 90 is vertical, right?
Mm.
Right?
You're right. Yeah.
And this one that I'm pointing at is is horizontal, isn't it?
Yes.
So a vertical line and a horizontal line meeting each other, the angle between them would be what? Established 90 degrees. So once you have that in any question, so whether they put that square box there, showing you that that square box, putting that square box there is just like an extra. But if the question has already told you that a vertical line met a horizontal line, or like they call them perpendicular lines, that's another name for vertical line meeting horizontal line. What angle must be there? 90 degrees. Did you get that?
Hmm.
So please don't forget. Again, let me say it. When a vertical line meets a horizontal line, the angle that you have between them is what? 90 degrees. Did you get that?
Yes.
Good. Another way of saying it is when you have two perpendicular lines, the angle between them will be what? 90 degrees. Did you get that?
Mm-hmm.
Okay. All right. So, um, like I said, I'm just looking at concepts around triangles. Okay. Now, the good thing about triangles is this. Triangles have a lot of applications. When I say a lot, I mean a lot of applications. Okay. Too numerous to mention. Okay. When I mean applications, let me give you an example. You know when you have word problems, right? Word problems that show you something from real life, and then you can translate that thing to a mathematical problem and then solve it. You understand what I mean, right?
Mm-hmm.
Good. So triangles have so many. I mean, I can't even if I start talking about them now, we won't probably finish today. Why? Because it's kind of exhaustive. Shapes find their way somehow into our everyday life. You can't just run away from them. They would be there at every corner. In fact, that you can analyze some things that you even see every day as either a triangle or a square or a rectangle or something. You know, it's safe to say that shapes are everywhere around us. Okay, so that's why you see that questions on triangles are numerous. I mean, I think the best thing is just for you to understand the basic things about those shapes, and then to understand the basic properties about a particular shape. Anytime you now need the ideas that you've learned about that shape, then you can apply them. I don't know if you understand what I'm saying. Do you understand what I'm saying, Mason?
Yes.
Okay. All right. So far, do you have any questions?
No.
Okay. All right. So let's look at. some examples. I'll just do some examples from right angle triangle. Okay, so before I go to those examples, let me show you an interesting concept. Now, we talked about, you remember when I was talking about isosceles triangles, right?
Mm-hmm.
Good. So now, once in a while, right, you find a triangle that can, be in two, I don't know how to put it, can be in two groups at the same time. Okay, let me show you what I mean. So let me just try and make this triangle fit. Okay, so I want you to take a look at this carefully. This triangle that I just drew now is a right angle triangle, isn't it? Okay, I want you to look at it carefully. Now, if I do this, I know that this is 90 degrees, right?
Mm-hmm.
I come and do this, and I put 45 degrees here. What do you think the second angle down there would be? What do you think the second angle down there would be?
45.
Now, that's correct. Now, can you tell me what kind of triangle this is, apart from just being a right angle triangle?
Is it is it an acute angle?
No, no, I said triangle, not angle. Acute
Oh,
angle, yes, are
what
different.
type of triangle? It's a right angle triangle.
Yes, it's a right angle triangle, but there's something else. There's another class of triangles that it falls into based on the fact that we have 45 degrees here and 45 degrees here. What would that be?
I'm not sure. Isosceles?
Exactly, isosceles. You remember that time I told you that when if you tip over an isosceles triangle, right?
Mm-hmm.
It may not look like an isosceles triangle because it's tipped over. But if you look at it carefully, it's actually an isosceles triangle, right?
Mm-hmm. Yeah.
This is an example of that. Did you get it now?
Yes.
So now I want to push this a bit further. Just follow me. Let's say that this place is 5 cm. This side of the triangle is 5 cm. Okay, let's just pretend it's 5 cm, of course. Okay. So what do you think will be this side? What would this side be?
Pardon?
What would this side be?
Would it be 5 centimeters as well?
It will be 5 centimeters as well. Why? Because we've established that it's an isosceles triangle, but it's just that it's what is tipped on its side. Okay, so
Mhm.
there we go. It's an isosceles triangle. Now, let's push this further a bit. So, there's this theorem that we have in mathematics called the Pythagoras theorem. Have you come
Mm.
across that theorem before?
I've heard of it, but I'm not. I haven't done it before.
Okay, all right. So let me just for the sake of our discussion, I'm going to quickly introduce it. Okay. So Pythagoras, of course, is someone to, I'm sure you'll be able to relate with that. And he was a mathematician in his time. Okay. So he came up with this theorem and that says that tells us some things about a right angle triangle. Okay. So basically, what he said was that every right angle triangle, okay, has um, every right angle triangle has, okay, let me do it. Let me do it. Every right angle triangle has a side that is the longest side, and that longest side is usually called the hypotenuse. Okay, so now that longest side is this side. That's the longest side. The side that is opposite the 90 degrees. Okay, that's the side that is the longest side. Can you see the shape I just drew now?
Mhm.
Okay. So that side is called the hypotenuse. And this hypotenuse is the sum. Okay, so now it's not just the hypotenuse, but hypotenuse squared is equal to the
Mm.
sum of the squares on the other two sides. Okay, equal to the sum of the squares on the other two sides. So that means if here is A and here is B, then H squared, the third side, the hypotenuse squared, is equal to A squared plus B squared. Did you get that?
Yeah.
So now if I want to apply to this triangle that we have before, that means that this place, this third side, which is the hypotenuse, will be equal to, don't forget to add the square, will be equal to 5 squared plus 5 squared. Okay. And you know that 5 squared is what? What's 5 squared?
Pardon, 5 squared is 25.
5 squared is 25. So you have 25 plus 25, which will give you what? 25 plus 25 will give you what?
We'll give you 50.
50. Now take note, you haven't found h yet. So you are looking for h. So h squared is equal to 50. What would I do to both sides to get h? Can you tell me?
Pardon?
What would I do to both sides to get h? If I have that h squared equals 50, what would I do to both sides to get h?
Would you split them?
What do you mean by split them?
Like, I don't know. Do the square root of H2.
Square root, that's it, that's right, the square root. So the square root of h squared will be 8, while the square root of 50, now I want you to look carefully at what I'm going to do. If this concept is not clear to you, then you just understand it for this class. Don't worry, whenever we have the opportunity to learn about swords, then you will learn it. But now if we look at the square root of 50, we know that 50 is not a perfect square, that's right. But then we remember that 50 is equal to what? 25 times 2, right?
Mm-hmm.
So if 50 is equal to 25 times 2, then, and I have that square root, that means instead of writing 50, I can write what? 25 times 2 and put my square root sign over it. And then square root of 25, I know is 5, so I can put that 5. But because I don't know, square root of 2 is usually, it's not a whole number. I can just put 5 times square root of 2. Okay. So did you get what I just did back there? Did you understand what I did back there?
Not really.
Okay, okay. But you know that the square root of 25 is 5, right?
Yeah.
Okay. Now, all I just did was just to, because I know the square root of 25 is 5, I simply found the square root and put the 5 there. But because the square root of 2 is not a whole number, you know that, right?
Mm-hmm.
It's
Yeah.
one in a hand. So in mathematics, it's just better for us to leave it as what? Square root of 2 and just put it beside the 5. So that will leave us with 5 square root 2 or 5 sod 2. That's how they call it. Okay. But like I said, I know it's new. Don't worry. By the time you guys are doing it in class, it will become more familiar. I just thought I should, mention it. But do you understand what I just did now? Did you have a fair idea of what I did, right?
Yeah.
Okay. All right. So I will not go too far with this. So that if you guys have not got point, then maybe by the next class you would have you know you would have probably gotten to this point. Yeah. So you have any question?
No.
Okay. So let's quickly do a recap of we what we covered today. So I started with just regular triangles, right? And I said something that the smallest shape you could ever come across in mathematics and in any field is what? A triangle. And then I went on to talk about a formula that links the number of sides to the sum of the interior angles of any shape. And we saw that that formula works perfectly for triangles. So that was a a good one. Then we now moved on to
Mhm.
now moved on to we now moved on to um other types of triangles, and then we now saw that okay, this sum of interior angles could be written in a different fashion, okay, which I explained how we got there. Then I now went on to say that since we know the sum of interior angles for any triangle, right, then that means that we could easily find um, um, a particular angle based on the fact that we know that the sum of the other two angles can be subtracted from 180. Um, then we now went on to talk about sum of exterior angles of any shape. We said that that could be, it's not a formula that's for that one. The good thing about it is that it's a given value. We talked about exterior angles, and I showed you an example there. Okay, that's where we had a plus b plus c equals k 60, and I drew a diagram there that referred to the a, b, and c. And then we went on to the next bit, which talked about the relationship between one interior angle and its adjacent exterior angle. By adjacent I mean the exterior angle that's just by its side in the way the shape is. And if you go back to this triangle and look, you understand what I mean by adjacent. Okay, so A and 180 minus A is the adjacent exterior angle to A. And then we now went on to talk a bit about right angles, and we said the right angle triangle is simply a triangle that has a right angle in it. And we said that right angle is what? 90 degrees. And then we said that automatically the other two angles must add up to give you 90. That the total angles, sum of angles in the right angle triangle would obey the rules for all triangles, which is 180, leaving us with the same fact that those remaining two angles are what? Complementary angles. Okay, and of course they're acute. An acute angle is simply an angle that's what? Less than 90, isn't it?
Mm.
So when two angles add up and they add up to give you 90 degrees, they are complementary angles. They complement each other in a way. Okay. So of course, I think by the side I mentioned that a triangle can be right angle triangle and at the same time isosceles triangle. We saw how that played out. And then I now pushed it further to talk about Pythagoras theorem in the mix. Okay, so um, I'll send you this uh, I'll send you this file when we're done on WhatsApp. Hope you'll be able to make good use of it. And if you peradventure have any questions or maybe anything here I I wrote down here is not still clear to you, you could ask me either during our next class or on WhatsApp like you've done before to explain. Okay, so I think we can stop here for today or tonight so that um possibly by the next class I think we should be able to have some more material to cover. All right. So how was your football game, the one you went for last? Was it on
It
Monday?
was good.
Okay. Did your team win?
Yeah.
That's good. At least it was worth it. Okay. All right. So we'll meet again on Monday by God's grace. That'll be 7 p.m. Oh, sorry. 5 p.m. your time. Is that? Oh, 6 p.m. your time. Sorry. 6 p.m. your time. Okay. All right. So enjoy the rest of your evening and weekend.
Thank you, Uncle.
Uh,
Right. Bye, Uncle. Have a good night.
all right. You too.